Hello guys, welcome to CodeSmash. In this video, I am going to explain how to find largest element in a given array. And the constraints given are these things. The array is named as ARR and the size is n varies between 0 to 10 power 6 and the value of the arrays are in between 0 to 10 power 6. So right now I will explain two approaches. The first one, brute force approach. And the second one, optimal approach. Okay, so we'll discuss the brute force approach first. So what will be the basic idea that anyone will get? So they are asking to find largest element in an array. So if we sort the array in ascending order, then the last element of the sorted array will be the largest element, right? So if we take an example, let us take n is equals to 5 and the values of 5, 1, 2, 4 and then 5 again. So this is the array given. First we will sort the array. So what will the array becomes? It will become 1 and then 2 and then 4, 5 and then 5. So if we look at the last element of the array, that will be the largest element because we are sorting in ascending order. So the last element will be the largest element. After sorting the array, just return the last element. Okay. So if we write pseudocode for this approach, so the name of the array is ARR, right? So we'll sort it. Okay. And then we will return the last element in the sorted array. Return last element of the sorted array. And then if we look at the time complexity and space complexity of this approach, so first let us find time complexity. As we are sorting the array, what will be the time complexity when we sort an array of size n? It will be O of n log n. And then we are returning the last element of the array. So the time complexity of returning the last element will be O of 1. If you look at the overall time complexity, it will be O of n log n. And if you look at the space complexity, as we are not using any external space for this approach, the space complexity will be O of 1. Okay. So the for brute force approach, for first approach, time complexity is O of n log n, and there is a space complexity is O of 1. Then we will discuss the optimal approach for this question. So let us discuss the optimal approach. So let us take an example. Take the same example as before. 5, 1, 4, 3 and 5 again. Okay. So what may be the optimal approach? See, if we declare an temporary variable outside the array, we will declare a temporary variable outside the array and then we will initiate the value of the temp with 0. As the minimum number of any element in the array is 0, so we will initiate the value of the temporary with 0. So any value in the array will be greater than or equals to the temporary. Okay. So after declaring the temp, we will go across the array. We will traverse across the array, and if you find any element in the array, greater than the value of temp, if you find any element in the array greater than temp, will replace the value of temp with the value of the element at that index. Okay. So if you find any element less than or equals to the value of temp, so I am telling that temp is greater than or equals to an element at index 8. If we found any element like this, we will just continue. Like, we don't care about the value at that index because we have found some other value which is greater than this and we are storing in the place of temp. So as we want to return the largest element in the array, we don't care about this element. Okay. Now we will make a dry run in this. Let us replace 4 with 6. That gives good understanding. So declaring the value of temp 0, and right now we are at index 0. Let's write here 0, 1, 2, 3, 4. So when we are at index 0, the value of temp is 0 and the value at that index is 5. Area of I is 5 inches. So as this condition is satisfying, area of I is greater than temp, will replace the value of temp with the value of the array at that index, which is nothing but 5. Okay, so temp become 5 here, and then we will go to I equals to 1 to the next index. So right now we are here. As the value of temp is 5 here, and the value at that index is 1. This condition is not satisfying. This condition is not satisfying. So we'll just go to the next index. We'll go to next index. So right now we are at index 2, and the value of temp is still 5, and the value at that index is 6. And then we found an element which is greater than the value of temp, which is nothing but we found an element which is greater than the largest element until that index. Okay, so we'll replace the value of temp with the value at that index. As this condition is satisfying at this moment, we'll replace the value of temp with the value at that index, and then we'll go to the next index as we are implementing it. 6, temp becomes 6, and we are going to the next index. As if you look at here, the value of temp is 6, and then the value at that index is 3. As this condition is not satisfied, we just go to the next index. So we are here it seems, and we are at I equals to 4, and the value of temp is still 6, and the value of array at this position is 5. As this condition is not satisfying, we go to the next index, and we just came out of the array, and at last we will return the value of temp, which is nothing but the largest element we found in the given array. Okay, at last we will return the value of temp. In this case, it's nothing but 6. So if we write pseudocode for this approach, let me write pseudocode for this approach. Let us write pseudocode for this approach. As we are declaring a temporary variable and initiating the value of the temporary variable with 0. After that, we are going throughout the loop. Okay, from index 0 from up to index n minus 1 and incrementing the value of index. So when we found an element greater than the value of temp, so I am writing right, if you found any element greater than the value of temp, we will replace the value of temp with the value at that index, which is nothing but area of I. Else we will just continue. And then at last, we will return the value of temp. So if you look at the space complexity and time complexity of this approach, first we look at the time complexity of this approach. As we are just traversing throughout the array only once, the time complexity would be O of n. And if you look at the space complexity, as we are just using an extra space right here, we are just declaring an external variable temp. So space complexity would be O of 1. So for the optimal approach, time complexity is O of n and space complexity is O of 1. And let us code for this question. So I'll write the C++ code, and you can find the other language codes in the editorial, and I'll give the link of the editorial in the description. So we'll write the C++ code. First I'll write the brute force approach. I'll declare the size of the array as n. What is the brute force approach? First we have to sort the array. We have to sort the array, and then we have to return the last element of the array. Return the last element of the array. Then we'll click on run, and it got accepted for 3 test cases, and we will click on submit, and it got accepted. And then we'll write the optimal approach for this question. So first we have to declare an temporary variable. We'll go to the description. We have to declare an temporary variable here and initiating it with 0 because the least possible value of the elements in the array is 0. And then we have to iterate throughout the array. Iterate throughout the array. And if we found any element greater than the value of the array at that index, we'll replace the value of temp with that element values. If we found any element value greater than temp, we'll replace the value of temp with the value of the element. And then at last we'll return the value of temp. So it should accept, and it got accepted, and we click on submit, and it got submitted. Thanks for watching the video. If you like my explanation, please like, share and comment. And you can find more editorials in CodeSmash, and I'll give the link of the editorials in description.